So let me just share my screen. Can everybody see my screen?
Yes.
Okay. All right. So thank you guys for joining us in this online event. We are Energy Tech Meetup, and this event is called Dine Discuss with ETM, and this is the second time we are hosting this one. The idea is that we are going to have a very casual discussion on sustainable energy and how tech giants are dealing with it. So feel free to grab your dinner, your favorite drink. We have ours over here. So let's just say cheers and take a drink so that we can start this one in a good mood.
Cheers.
Bye.
Kanpai.
Kanpai.
All right. So I'm just going to do a very short introduction of ETM. It should take just about 5 minutes, so don't worry about it. So ETM is a community for anyone who is interested in innovation related to energy and technology. So the main point is the community that we are trying to build over here. And we believe that energy innovation needs a lot of diverse fields and expertise to get into these strong innovative ecosystems. So we are so happy to see that in our networking sessions, we have not only students and technical background people from corporate people, not only from the energy sector, but also from other backgrounds that really builds up to our mission of creating the diverse field of expertise. So before, I can say pre-corona era, we were doing a lot of events and seminars in offline settings. And one of our main projects were having this networking opportunity after the event. So that was our main focus, events and networking. We also engage with our audience and our speakers in different ways. There are similar dinner events and others. So these are on hold right now, unfortunately, but we are doing as best as we can in online settings. And the final thing that we do is that we share insights with our audience. This is done through the Medium platform. So we publish summaries of our events in short digests, and these are available for everyone to see. So some of our most, how can I say, revered community members may not join one of the events, so they can follow up by using the Medium platform. All of these are done because of our 4 core values of commitment, community, diversity, and transparency. So everything we do, every event and every discussions we take part in are the reflections of these core values. Right. So this is a breakdown of our recent participation. As you can see, we have a lot of participants from the company and startups and students. But as we said, we really want to create a diverse community. So we are really working hard on the other sectors, the students and startup sections. We also have some participants from the academia section. So we are really happy about that, but we are trying to make it even more diverse in future. So this is the team that makes it all happen. Amanda and Grace are the 2 founders who founded it in June 2019. Today, I think Amanda is with us. So may I ask her to say a few words?
Hi, I just want to say thank you so much for joining, and I'm really happy to see the community growing and seeing the support within the community and like connectivity within the community. So yeah, thank you for your support. And anytime if you want to get involved or be a speaker, be a partner, volunteer, or anything, be an organizer, please reach out to us as well. And have a good time. Dine and discuss.
Right. And just a little fun fact, the 8 faces you see here are from 8 different nationalities, from 8 different perspectives and languages. So we are really trying to bring together all of these point of views and build our global team network. Right now, ETM is based in Tokyo, of course, in Vienna and in Berlin. So we are really trying to create a global community that supports energy innovations. Right. So this is just a promotion of our next event that is going to happen during September, and we are hoping that we can do it in offline, but it depends on the situation, how the coronavirus situation plays out. But let's see. It's going to be in September 24 to 25, and we are going to participate in September 25. All of the information are in our LinkedIn and Facebook pages. So please follow us over there and you can get the information on the events. We would also like to promote one of our events from ETM Vienna. And this is the discussion on solar energy parity. It's on August 6th, but it might be a little difficult for Japanese audience because the time is not very convenient. It's going to be around midnight, but hopefully our European viewers can join it. Okay, so this is the end of our presentation on our part. So we are based in all the major social networking sites. You can scan the barcode now or just search for Energy Tech Meetup in Facebook, PRTX, LinkedIn, YouTube, or Medium. We are really appreciate if you could join us in those discussions in the Facebook networking sites. Right. So today's event is actually in partnership with Impact Hub Tokyo. So I would like to invite Yuko-san to give an introduction on Impact Hub.
Hello, everyone. I'm Yuko from Impact Hub Tokyo, and I'm here to shortly just introduce about Impact Hub Tokyo. Kabir can just control the slide. It's fine. I'm gonna tell you when to go to next slide. So yeah, Impact Hub Impact Hub Tokyo is a community of diverse people and entrepreneurs, and also a co-working space. And as Impact Hub, as a global ecosystem, there are a lot of Impact Hubs around the world as well, and we are one of this global ecosystem. And we have this idea that to have a community that's beyond the shared office. And you can go to the next slide. So Impact Hub Tokyo, we believe in the value or concept of learning from each other and knowledge sharing. So that's why we are more focused on the community building part. What we say is people first, place later, rather than co-working space. So we do have a co-working space for daily life for entrepreneurs, but we are more focused on having a community, and we think it's very important, necessary for the concept of co-learning. It's very important for the entrepreneurs, for them to grow and help each other. So yeah, and with Energy Tech Meetup, we have a joint focus on sharing knowledge and community as well. You can yeah, and then because of that, sorry, can you go back to the previous slide? So we have, for example, accelerator programs for entrepreneurs, which is we focus on the team learning, as I said, based on the concept of co-learning. And we also have very lively kitchen. I don't know if any of you have visited Impact Hub Tokyo before, but we have a space for communication, and we have coffee places. So if you have any chance, so the location is in Meguro. So Meguro in Tokyo. So if you are interested in visiting us, you're more than welcome. We have yeah, and you can go to the next slide. So we organize events such as Energy Tech Meetup, and also we have another event called Fuck Up Nights, which is the event to share the failure, the experience of the failure and the learning. So this event is happening quite a lot with Energy Tech Meetup and Fuck Up Nights. We have been sharing the value of the sorry, I'm a bit nervous. I got a bit nervous. Sorry. Yeah. Yeah. So you can actually also check out what is happening with the Fuck Up Nights from the QR code. Yeah. You can go to the next slide. Yeah, so for more information, you can go to the website. And at the moment, we are working on the English website, but you can access to the Japanese website and check how it looks inside as well, and what kind of events and what kind of programs we have. And you can also access to our Facebook page. And if you're interested in to know more about us, you can contact me. You can contact via website. There's a contact form. So actually, I'm leaving quite soon. So if you have any questions, if you had any wonderings, then you can just send us the inquiry from the contact. Sorry, I got a bit nervous, but that's it.
I would just like to say that Impact Hub Tokyo has been such a big friend to ETM ever since our beginning. And it's not that they have amazing facilities, but the people working there are just wonderful. Impact Hub Tokyo has our seal of approval, Taikoba no Semasyo. So we really hope you guys will see the events and also their facilities in Nakameguro, in Meguro, right?
Thank you. Thank you so much.
Okay, so I think we have been waiting for a long time for the talks. So let me just introduce our first speaker. We are so excited to have two very distinguished speakers today from Amazon Japan and RECAN. Our first speaker is Rita Monteiro. She's joined Amazon in 2017 as a manager in field operations in UK and France, and then passing through the supply chain strategy. Now she is in Japan working with sustainability strategy for Amazon within operations. And I think for me personally, it is so impressive to see that Rita has spent 8 years working in human resource consulting in Portugal, West Africa, business management in Southeast Asia, and entrepreneurship in all 3 regions. So a true global citizen we have as our first speaker. So Rita, whenever you are ready, please start your presentation.
Thank you so much for the introduction, Kavir. Let me share my screen. Let me see if I got this right. Okay. So very nice to meet you, everybody. I do have a very diverse background, and I'm finally working on the area that I was hoping to work since the beginning. So I'm really happy now to also share what Amazon is doing in Japan and also globally. So let me go here. So in the last year, we made several announcements with the creation of the co-funding of the climate pledge with
Rita,
sorry?
Excuse me. Yes,
Mm-hmm.
we can see your presenter view.
Mm-hmm.
We can see the presenter view, but not the presentation.
Oh, no? Oh,
yes.
Okay, sorry.
So,
I don't know why. Let me try again. Okay. Is it work now? Is it okay now?
Yes, right now it's
yes?
perfect.
Okay.
Please go ahead.
Okay, sorry. So as I was saying, since last year, we made quite a number of different commitments in Amazon that are challenging all our business units to reach carbon neutrality by 2040, which is 10 years ahead of the Paris Agreement. We did this by co-funding the climate pledge with Global Optimism. And recently this week, we also announced that we joined Women Business Coalition that gathers over 1,200 companies in an effort and a collaboration towards decarbonizing at different levels and verticals. So in Amazon, in a quick nutshell, we plan to reach carbon zero by 2040, as I said. We made a commitment specifically in our logistics, where we hope to achieve 50% of shipments without added carbon by 2030. This means renewable energy, transportation, and packaging, so eliminating carbon from all 3. We have a very large team and a lot of partnerships working on measuring and reporting, and you can consult our website for our latest announcement on the different carbon footprints that we had last year. We anticipated our previous renewable energy goal from 2030 to 2025, which we are working very hard to achieve across all global markets, and which we will focus on today. We also announced the $2 billion climate pledge fund that will help to accelerate supply chain and the different advancements that will help us reach this carbon neutrality goal. And we also, last year, we launched a $100 million Right Now climate fund that works on reforestation with Nature Conservancy. So very quick nutshell on this. My specific area is around operations and fulfillment centers. So I will focus a little bit just explaining what we are doing to reach these different goals that are targeting operations. So as I mentioned, we have the Shipment Zero that is focusing on eliminating and redesigning our packaging. We know that sometimes our packaging is not the best. We are working very hard to improve that. We are also working on decarbonizing all our supply chain. So all from the transportation from fulfillment center up to the customer. So with zero emission vehicles, focus on electric vehicles, hydrogen, or hopefully in the future, other types of biofuels that are currently in development globally. And also, again, as I mentioned, the renewable energy goal that focus on reaching 100% renewable energy by 2025. With this, we are also focusing our efforts in improving our energy efficiency across all our buildings, and also understanding what is the impact of our infrastructure in the environment, and working towards building design to improve the materials we choose and the equipment we choose to ensure that we have the most optimum sustainable options across our global infrastructure. And finally, culture is very important, and we have very active Amazonians collaborating at different levels to not only share the message of sustainability globally that impacts our business life, but also more importantly, our personal life, in order to for us to create meaningful change towards the future. Focusing on renewable energy procurement, which is what brought us here today. So Amazon standards are very demanding, if I can say otherwise. So for our 100% renewable energy goal, focus on traceability and additionality. So our methodology is we count for the renewable energy that exists in the grid, and we add up the renewable energy projects from Amazon divided by our total consumption of energy. Currently, we have over 91 global renewable energy projects, totaling over 2.9 gigawatts of energy capacity and counting. So there's a new projects coming up almost every week now. We are focusing these on utility scale projects with solar and wind, and also on-site solar systems across our fulfillment centers. Of course, this goal is for all the businesses, so AWS and Amazon included. And we know that the only way we can reach this goal is by going to utility scale. So this is why our investment is so heavy in this sector. I added here a quick link if you are more curious about our methodology on renewable energy. We are becoming very, very public about our policy and our strategy. So feel free to consult to identify additional details. A little bit about our renewable energy projects. So we have wind farms all across the globe now. We have very large solar farms across all 3 continents. We have in Europe, no, actually 4 continents, Europe, US, Australia, and India, if I'm not mistaken. Sorry, it's hard to keep count and trying to visualize the map. But we have a lot of projects everywhere. And of course, we are trying to include as much as we can on-site solar across all the countries where we operate, so where we have fulfillment centers, and mostly fulfillment centers because of the roof surface that we have included. Very quick summary, we have a motto in Amazon that we say it's always day one. And I gave you a very, very quick introduction of what we are doing globally. I am open for questions, but we have the motto of it's always day one, because we don't want to settle, and we take our sustainability efforts in our decarbonization very seriously. And we have really a lot of people working on incredible things to minimize the carbon footprint of our global business. Thank you. Thank you, everyone.
Thank you so much for your presentation, Rita. And I think this mentality that it's always day one or it's always a growth opportunity is something the startups say when they are growing, and they never want to stop growing. So I really want to discuss this concept with you in the panel discussion. So for the audience, if you have any questions, you can write them in the chat or hold on to them till 7:30 when we will start our panel discussion. But now it's time to move on to our next speaker. And our next speaker for tonight is Dr. Satoshi Matsuoka, who received his doctorate from the University of Tokyo in 1993. And right now, he is the director of RIKEN Center for Computational Science. And I think he will, of course, present about Fugaku. So let me waste no more time. Satoshi Sensei, you can go ahead.
I think he's muted.
Satoshi Sensei, we can't hear you. Can you please unmute yourself?
Oh, sorry about that. Yeah, so last talk basically talked about how to generate electricity, but this is about the IT innovations to actually build infrastructure that don't use as much electricity, and both are very important. So, you know, at Tokyo Tech, where I think Amanda is, I've been building a series of supercomputers, and you know, way back, and now I've handed off to my successors. But you know, in the DIA course, the greenness have been very important metric. In fact, many of our machines I built basically have won the greenest supercomputing accolades over the years. Savannah KFC, you see bottom center, and the latest production, Savannah 3.0, which you see still on campus, that got #1 on the grade, what's called the grade 500, you know, as being the greenest supercomputer in the world. And when you look at the technologies involved to make things green, the enterprise business clouds, for example, we see in Amazon, there are, they use techniques like server consolidation, dynamic voltage frequency scaling, and to some extent, I think it's a little bit become popular to use some novel cooling methods, but but mostly Amazon and those companies buy existing devices, and there's not much room for innovation there. Whereas for HPC, we can't use consolidation because all the machines are running at full speed. You know, we can't throttle down the machine because the machines are running at full speed. So we have to resort to the most advanced technologies, and it's our mission to build these and actually lead the industry so that the other parts of the industry can adopt our technology methodologies to move things forward. And so, build a machine like Savannah 3, but I'll get to, in the interest of time, I'll get to, this won the Green 500 Award as well. But in the interest of time, we'll get to my current center, which I run, which is the flagship supercomputing and HPC center in Japan, backed by the government, and one of the 12 weekend centers. But I'll skip over the descriptions. If any of you interested in coming to weekend for your future career, let me know. So this new machine, Fugaku. So we've been building this, planning this for 10 years, and as we have been operating our predecessor machine, the K computer, which was the fastest machine in the world back in 2011. But it was quickly, our experience in building Savannah and other machines, of course, was very obvious that we have to pursue greenness to the limits, the energy consumption being top of the world, in order to attain to come close to any of our metrics regarding the stuff we want to run. We have all these capacity requirements for machines, right? Because we want to solve all the world's problems in our applications, actually including all the energy problems. But, we just have to build the big machines for it. But, what the scientists request, we cannot build, because if we build with existing technologies, the machine would just be too big, use too much power, and not sustainable. So, we had all these research projects over the 10 years to realize technologies that allow us to build the fastest supercomputing in the world, but also the most power efficient supercomputer in the world. And Fugaku is a result of that. It's the largest and fastest supercomputer ever. It was sort of, conceived with the application's first R&D challenge, but also it was, sorry for the Japanese underneath, but also it was built with a moonshot research R&D target. We had to build a processor which is 3 times more power faster than any other chip in the world, including ones by, let's say, Intel. Also had to build a chip that's 3 times more power efficient than any chip in the world, including those by, let's say, Intel or AMD or so forth. Also had to be general purpose. So it had to be, some chip. We chose ARM. So to think of this new chip we just built as something that runs the same code or program as your smartphone, but maybe 50 times to 100 times faster per chip. And of course, you have to build all the modern features like AI acceleration. So think of a Fugaku as equivalent to something like 20 million smartphones, which is about the number of smartphones sold in Japan in a year, or maybe like 300,000 servers, maybe a few Amazon data centers, something like that. And again, equivalent to maybe about a shipment of all the servers in Japan. But we have to cap it up below 30 megawatts. So that was a huge challenge, but we achieved it because it was a national flagship project, and we got all the brains in Japan, including the ones in academia, all the way up to industry to really commit to this project. So like I said, the chip we built, this one, is exactly that. But also, again, it's a general purpose CPU, so it runs Windows, runs PowerPoint, just name it. And so what we do, we take the chip we have designed and built, and we assemble 160,000 of them into a single computer. And that's the that's the genesis of the machine, and it's the first so-called exascale machine in the world. But again, it was only possible because we have built a chip that's not only fast, but also 3 times more power efficient. That is to say, if you had built off-the-shelf components, the machine would have been 3 times bigger and used 3 times more energy and 3 times more costly. And to prove this, again, this machine became, the prototype of this machine became #1 in the world on the Green 500 metric last November. And, but what's important is not the fact it became #1, but the fact that we had really proven that it is 3 times more power, 3 times faster, and also 3 times more power efficient than any other chip, a CPU, general purpose CPU in the world. So we're #1. The next next CPU, all the next succeeding machines were GPU or some special chip machines, so they're not general purpose processors. The next top general purpose processor machine was a Xeon machine, Intel Xeon machine, but number 37. But again, the ranking is not important. But the metric, how much compute you can do within a watt, is something like 5.8. And Fugaku AC4FX chip is 16.8. So that means it's 3 times more energy efficient for this particular benchmark. So we had proven that actually we had built a chip that's more 3 times efficient. And you may ask, okay, so that's for this particular benchmark. What about general applications? Well, here's a list of all the some of the major open source and also some proprietary HPC codes, includes CFD, ab initio calculations, seismic wave propagation code, climate code, blah, blah, blah. And again, you see that throughout all the codes, the chip is 3 times more power efficient. And by the way, I don't show the graph for the speed up, but also it's also 3 times faster. So, it's a machine that's, again, huge. It does use up to 30 megawatts of power, which is about the same power as a Tokyo Disney Resort. But again, I can assure you, we're making very good use of the power. Now, the recently announced IC 2020 June, this machine was also recognized as fastest machine in the world by all metrics, not just the famous top 500, but across all the metrics, including what's called HPCG, HPLI, Graph 500. So, but in a nutshell, this is a machine that's faster by any other machine in the world, including those in the US or China. Not only it's faster, it's faster by several factors, as you can see on the rightmost column. Like 3 times more faster, the summit of the DOE, Oak Ridge machine, and so forth. But again, it was only possible because we had built a very power efficient chip. And that's very important moving forward. And of course, it's not just the benchmark. My final slide here, this is really important for solving the global world crisis. Again, something like energy, solving some of the energy issues is one of the targets. But one of the things we've been working on very aggressively is the how to solve the COVID-19 crisis. So there are a number of projects, including the ones you see here, that's been running on Fugaku, that's providing innovative results. Now, the machine's actually not officially in operations yet, but we started work machine and operate in pre-production a year ahead of advance to cope with this crisis, well, a year. And maybe you have seen some of the people in Japan may have seen the video of like the droplets and aerosol infection simulation, but that's not all. We're doing various types of drug searches. We're doing societal simulations, virus, direct molecular simulation virus. But again, these machines are critically important for society to move things forward. But also it's important because we have developed technology that will drive the next generation. So, okay. But that's it.
Can you be more indent?
Hello? Okay, so that's it. And yeah.
Thank you very much. Thank you very much for your presentation. And I understand it's a very brief introduction to the system, but hopefully we can continue the discussion in the panel discussion session. Thank you very much.
Right.
Okay, so does anyone have any questions for our speakers? You guys can enter it in the chat or just unmute yourself and ask directly to the speakers, no problem. Well, let me start the discussion. I think I would like to ask Rita about what do you think is the biggest challenge for you to support sustainable energy from Amazon's point of view? Or later, I would also like to hear Dr. Satoshi's insight into this point.
Of course. So our goal of reaching 100% renewable energy, we work, as I mentioned, with traceability and additionality, which proves to be more difficult in certain markets over the others. In Japan, particularly, we were still attached to the FIT for solar, and we have a very high feed-in tariff for wind that is a blocker for private corporate investment into this field, because the developers, of course, prefer a higher return that is provided by the incentives from the government. So we are working with different partners, not only in Japan, but across the regions where the market is not so much receptive to these features. And we are working to ensure that we are able to secure projects to meet our commitments locally and globally. At the same time, we are making a lot of investments in energy efficiency across all our facilities. The more energy efficient we become, the less we need to procure. And this is a parallel effort that goes hand in hand from our side. I would say that these right now are the two main challenges that we are focusing our efforts on.
Thank you very much. Dr. Satoshi, what do you think RENEABLE's primary challenge, the most important bottleneck?
Well, we are we're the national lab, the premier national lab in science. And so we have, and of course, we represent the HPC and the simulation and the large-scale AI community in Japan as a whole. So, this whole thing about the challenges, they are, of course, they're, as I said, of course, in terms of things like IT, there is the challenge of both generating electricity to sustain these infrastructures, and also these infrastructures being very power efficient in order to be sustainable. And both are very important. And things like supercomputers actually help to solve the challenges in both. For example, if you look at a data center, the data center energy improvement with the same amount of compute capacity has only improved by a factor of 5 in the last 10 years. And this is not my, that's not my saying, it was the number provided by Google. So it's pretty reliable, and they're on top of it. Like a machine like Fugaku, we improved the energy efficiency by factor 20 in 10 years. And that's because we have a very aggressive national project moonshot-like technological advancements, way beyond what if left to private industry would be a very incremental advance in these chip companies. But being a national project, we made very aggressive advances. So these kinds of technological advances in IT, where we consume power, is very important. Now, where we generate power or we store power and so forth, again, we need to be very, very aggressive. For example, how to generate electricity, the wind turbines or turbines. There's a lot of room for improvements. For example, what the industry uses in terms of generations of power in gas turbines, the simulation capabilities that these industries use are way behind the state of the art. So what happens is they cannot build turbines that are big enough to be more efficient. Right? So, and this is only possible by the utilization of very large scale machines, not just ours, but those that DOE has or stuff like that. Or things like energy storage. Storage is very important. What people do now, what power companies do now is starting to use batteries, but it's still not very efficient. So they pump up the power along the dam in order to basically absorb this fluctuation of power. But that's only like 1/3 efficiency. Right? And batteries, you may think is efficient, but they're very expensive to produce energy-wise. So actually batteries are not very sustainable currently. So again, advances here are critically needed, like solid-state batteries, or any sort of power grid being more efficient by use of new types of replacing silicon to gallium nitrate type of power converters. Again, this requires lots of new developments. So so all of these, the science and technology, the research, and all the simulations capabilities that we provide. But it's not just us, other people provide, are critically needed. And we really have to be much more innovative in order to be much more sustainable, because that's the only way. We cannot, if we just progress incrementally, we cannot be sustainable at all. There's just no way.
I see. Thank you very much. Are there any questions from the audience? Would anyone like to ask a question to our speakers?
I had a question. It was about Rita. So.
Yes.
About right now, Amazon is dealing with a lot of data and need to store a lot of data. But how do you plan to manage this data in the future? And how do you plan to use this renewable energy to store that much data, because it will be growing up in the future?
So our renewable energy goal covers all businesses, including retail and AWS. And we know that AWS with the data centers are a big impact. I am not working with AWS at the moment. I'm only working with the retail side. So I am not able to answer specifically questions on the systems and the innovations that we are creating in our data centers. I know there is a lot ongoing, but what I can do is I can point you to the webpage where we speak about a study that we commissioned to understand the opportunities for energy in AWS. I'm sorry, I'm not able to exactly answer you on the data part because I'm not working in that business unit at the moment.
No problem, it's okay.
I'll share with you.
Okay, thank you very much.
Thank you. So we have a question to Dr. Satoshi in the chat. It's from Lawrence, I think. So it says, how much better in energy efficiency is Fugaku compared to ICE, AI bringing cloud supercomputer? It was not, however, designed for extreme energy efficiency. So a little bit of comparison.
Which one? Which computer?
I think ICE AI bringing cloud supercomputer.
Oh yeah, that's the one. I also built that. So
right.
Yeah, the two machines. Fugaku is a little bit more efficient, not by much. That's a very good question. How it's apples and oranges, but ABCI is a GPU-based supercomputer. so it has its merits, but less general purpose. But that's great on stuff like AI because it has some special features to accelerate it. Heroku is a much more general purpose. It's a CPU-based machine, and although processors have some GPU flavor in it, but still it's an ARM processor. So, like I said, every CPU core, there are 8 million CPU cores in Heroku. Every core can run PowerPoint. Right? So, yeah. The point being that we achieved a energy efficiency of ABCI level energy efficiency using but on a conventional CPU. That's the whole point. If you just compare the numbers, they look similar, but Heroku in some sense is much more advanced because of that. Yeah. So maybe I have my heart's in both machines because I'm involved in both.
Yeah, so my name is Lorenz Conrad, and I'm working for AIST, but as innovation coordinator. So I cover a lot of fields, and I have visited the AI supercomputer. I didn't know that you are also behind that.
No, I conceived it.
Okay. So, but anyway, I think it's a very important thing to think about energy efficiency because supercomputers use quite a lot of power. So I think it's a very good direction to go.
No, it's not just supercomputers because basically the modern data centers are of course big collection of big machines for very large approximation. They're very similar. And also, if you look at the workloads that these data centers are hosting, with all the advanced AI, like Facebook, like every picture that comes in goes through some AI inference to see, if it to match against this huge database of pictures, which are sort of concentrated into the neural networks. But these use up a lot of power. So increasingly, data center workloads are becoming from like supporting retail stores to those very advanced AI whose work, and also some simulations, which are very much HPC workloads. So, it's very important that we develop technologies on the IT side to make them as power efficient as possible. And of course, from sustainability perspective and also from business perspective, because there are a lot of costs involved in driving these infrastructures that the most advanced technologies go into these data centers. And actually, companies like Amazon are very, very aggressive on that, actually, adopting these latest technologies. But having said that, Amazon, as much as these companies try, there are always trade secrets that they cannot reveal 100%. I think it's the job of AIST or institutions, public institutions like AIST, or like DOE centers, that we can be much more public about what we do. So we can demonstrate what we do, hopefully the private sectors will pick them up because it's very hard for the private sector, they're competing with each other to reveal the latest and greatest. So it's our role to, to be an exemplar to advance the field forward.
Thank you very much.
Yeah, and that's why. That's one of the reasons we built. We built ABCI to be an exemplar, not just the production machine. Yeah.
Thank you very much, Dr. Satoshi, for the insight. And I think he also mentioned that Amazon, large corporations like Amazon and others, they tend to be very aggressive with their goal setting and target setting. And I think Rita also mentioned that it's always day one. It's always get go every day, each single day. So where does this mentality come from, and why does large corporations adopt this mentality? Can you give us just your honest opinion? That would be also really nice.
From my side?
Yep.
So let me quote the big boss on this. If I find, because I think it summarizes really well. You know, they want companies are the ones that are always at the beginning of their potential. This is our motto, and they want companies are, you know, always trying to understand how they can create meaningful actions very aggressively and very energetic. They too companies have the mindset of stagnation. Now is they are more settled. And as Jeff says, day two company mindset means stagnation followed by painful decline and death. A little bit traumatic. But this is exactly what we fight against in Amazon. And this is why we anticipated already the very challenging goal of reaching 100% renewable energy from 2030 to 2025 globally, despite the different challenges we have on specific marketplaces like Japan. And specifically APAC region countries. However, we are focusing, like I said, really hard our efforts in leveraging our global infrastructure and our global partnerships to ensure that we are able to meet these goals globally and as much as possible as well, like I said, in the different marketplaces we operate. So it's always about creating meaningful action. And we also recognize that with our scale and our size, we need to ensure that we provide the message that if we can do it, then anybody can. Well, because we have cloud, we have all the infrastructure, we have manufacturing, we have logistics. You name it, we have it likely. So, and we are still going to achieve this goal, taking into account the whole umbrella of the business. So we feel that is our duty as well to showcase and call others to action and collaborate with others that are already in several stages, different stages of advancement in different sectors with us, so we can all work together towards this goal, because this goal is not Amazon goal, is the goal that actually all the companies should have based on their ethic behavior. If we say, I don't think it's no longer a choice or a nice to have, it's really a business direction globally that all private sector and public sector should have.
Okay, you just mentioned about the goal is not only for Amazon in a specific region, but it's global. And you have experience of working in Europe, West Africa, East Asia, and you have also been to Boston, if I'm not mistaken. So what do you think? What is the challenge in case of implementing these goals in a global sector? Is it difficult in certain areas, easier in others?
It depends how much is the public policy advanced in specific regions. Now, Europe, for example, is very advanced in its regulation to ban plastics, to decarbonize. They are now launching a bill that will ban all fossil fuel vehicles in Europe at, I think, 2035, if I'm not mistaken. And other regions like Japan are not yet looking at this sector. Japan is a very long-term thinking country that is, going from, it seems to be going from a hybrid model to a hydrogen model, but it's a lot like chicken and egg thing. We are still trying to identify, we need the infrastructure to create scale, but we cannot get scale without the infrastructure. So what comes first and what comes the first investment is a decision that is being made in this specific region. So it's really thinking, how can we localize our goals, our global goals in the different regions that we operate, and they really require different strategies depending on the country. Now, even our facilities in Japan are different from other regions. Now, we know real estate is not an easy topic in Japan, and therefore it's just more challenging overall. Now, for example, our buildings and all the logistics buildings tend to grow up, which means that we have less roof surface, which means that we install solar panels, but they don't have as much capacity as some of other buildings we have in England or US or India, for example. So yeah.
So public policies and private companies sort of need to work together to get this goal, right? Yep.
Yes. Of course, and leveraging as well all the partnerships with startups. Now, we have been very proactive in partnering with different startups and different special. I'm sorry, I'm missing the word in English now. I missed the word, experts in the field to really help us advance again local actions, global actions. You know, we have to look at the whole umbrella if we want to make the meaningful change happen. So.
Right. Thank you very much for sharing your opinion on this matter. We have a sort of technical question in the chat. This is directed towards Dr. Satoshi again. What do you think is the bigger challenge in case of energy efficiency? For example, managing the computer resources like CPU, memory, storage, etc., or the space for it, or the network connections, efficiency, heat. So if you could answer that question, that would be awesome.
Oh, well, you know, there are many challenges. I think the biggest challenge, of course, the machine itself to be power efficient in the first place, because that's the, you know, that's the basis design, right? Yeah, I mean, you can control it, but you know, it's like building a car. But you know, no matter if you drive a car, you know, you buy a car, but if the car is a gas guzzler in the first place, it's very hard to get energy efficiency irrespective. So the car has to be very efficient in the first place, and then of course you drive it or you control it in a way that's more that it would be that increase the fuel efficiency. You know, you don't step on the gas and so forth. It's the same with computers. You have to build a very energy efficient machine, and of course the associated infrastructure in the first place, like cooling and power delivery. So we have to have that as ground base, as the basis. And then, yeah, well, you know, then you can, also the machine will provide all the knobs and controls to be able to monitor and also to control the power. That's also important because, you know, if you don't have all the intricacies of being able to control it, you can't control anything, but that's much harder than you think. For example, K really didn't have much, the K computer, the predecessor of Fugaku, didn't have much of a control. So it was very hard to exert any sort of power-saving policies, in addition to the K now being sort of moderate in power efficiency. So Fugaku, not only, so what we did with Fugaku was, again, as a basis, we built something that's extremely power efficient in the first place, you know, ground zero. And then we had all these monitoring features to be able to monitor the use of power in a very meticulous way, in a very, you know, at various, you know, sections of the processor, the machine, and so forth. And then we also added lots of features to be able to control the use of power in the various situations. And then, you know, we're adding all the software and algorithms and all the layers to be able to the effective control, you know, having artificial intelligence to control the power use, to optimize the power usage. So, you know, it's a very holistic process. But again, the biggest challenge is to build something that's power efficient in the first place. Right? Otherwise, you know, you can't, you know, there's not much you can do. And that's where technology, that's really where the most important core technology comes in. Like, you know, the semiconductor process technology, the architecture technology, and also, you know, some of the others that allow you to, the packaging technology that allow you to build these very power efficient machines. And but that's really hard.
Yeah, that also aligns very, very much with what we are doing in Amazon now, thinking about all the equipment, all the building design, and then of course implementing very smart energy efficiency methods, so we can measure all the equipment live and understand how much it's spending. And I guess for the data centers, geography also matters. No, you're not going to build a data center in the middle of the desert. That will not be very efficient energy-wise. But yeah.
Maybe not so much. Yes, you can. I mean, well, yeah, there are ways to do that. Yeah.
Yeah.
Anyhow, yeah, but it's hard to get to. That's a problem.
Mm-hmm.
So,
well,
Rita, yes.
Water
Please go ahead. Please go ahead.
Yeah. The cooling water is expensive in desert. That's the bigger impediment. It's not so much the data center itself. It's not the temperature. People may think it's temperature, but it's not. It's the water. And the water is very expensive in this desert. So that's the impediment. Okay.
There are just so much technical details into these things, but let me ask Rita one more time that you just said you guys are trying to measure the energy efficiency or sustainability of your operations. And you just said that you actually reduced the time scale from 2030 to 2025. That's a very aggressive goal. At this moment, do you think you guys are ready to meet that goal in 2025, or it's just something to say that we have this ambitious goal? What is Amazon's policy right now?
We never say things just for saying. I can
All
assure
right.
you that. I can assure you that when this goal was announced, we were guessing it on the shareholder letter from Jeff B 2 months ago. He was hinting that he was planning to challenge the teams to anticipate the renewable energy targets. So we were kind of preparing for that, but when it was officially announced internally and then a couple of days after externally, so this is the time frame we operated. I have to say I spent a few nights blank thinking about it because the whole timeline has been very much anticipated. So of course, when we have these challenging goals, we ensure that they are challenging enough and that we double our efforts to meet it. So it's not something we are saying for saying. I definitely can assure you that we will do everything that is in our power to achieve it.
Right. Amazon being the leader in case of cloud services and in many other sectors, it makes a great impact, right? If the leader is showing the way, if the leader is accepting challenges, then it also encourages the other big players to do the same.
Yeah, yes. So recently we joined We Mean Business Coalition. It was announced earlier this week, which is, let me get the numbers correct, because it's a couple of $24 trillion combined effort from 1,200 companies globally, including Apple, including Amazon, of course, including other big tech companies. So I think originally it was funded by IKEA, if I'm not mistaken, and now is expanding globally. So this kind of shows our effort that we are not arrogant enough to go it solo. We understand these are very challenging goals and we need to operate at different business levels. No, it's not just data centers, it's not just logistics, it's not just fulfillment centers and manufacturing, is all of it. And also then when we go to US, we still have the Whole Foods, which is very heavy energy-wise because of the refrigeration that occurs with fresh products. So we are including everything that is under Amazon umbrella under this goal. And that's kind of what it makes it so challenging. And this is why we created a climate pledge and why we joined Women Business Coalition, why we are creating several funds of investments to ensure that we have the correct infrastructure in place to create these partnerships towards achieving our goals.
Okay, Dr. Satoshi, can you give us your opinion on this matter?
Well, so I got to take a very holistic view of where the energy is, world energy being used. And so, for example, data center uses about 1% of global energy, okay? But fertilizers actually use more. Fertilizer production uses more energy than data centers. And that's not very obvious, but you need fertilizers to have sufficient food production to keep the world alive. So, so what do you do? I mean, so the reason why fertilizer energy consumption is so significant is that it uses this what's called Haber-Bosch process, which was invented like 100 years ago, more than 100 years ago. But people have challenged better ways of having better catalysts to required to have much lower requirement in terms of energy, but have not been successful. But with the advent of these very fast supercomputers, and maybe with quantum computers, some are kind of say it can be cracked using quantum systems. Some say with very, very fast supercomputers we can crack this. If we crack this, we can save as much energy as what the data center is using right now. So, there are, as much as we try, and of course we try because we need, the other reason why we want to reduce power consumption is we want our smartphones to last longer, to develop more power efficient chips so that, we can talk long, we can watch YouTube videos much longer on our smartphones without charging. But of course, we want to be green overall. But it's a very complicated problem, and but IT holds a lot of promise in terms of being able to crack these problems. Same with COVID, same with other types of energy problems, same with things like COVID, things like disasters. So again, advanced technology, cutting edge technology development is the only way we can solve these problems. And it's a coalition of public sectors and private sectors. They can, each with its own pros and cons. Of course, private sectors have certain pros, but there are certain things private sectors can't do. And similarly, what we're very good at, like national labs and public sector's research, and also the government very good at doing, but something we can't do. So partnership there is very important. So like we can partner with tons of companies worldwide in order to attain our research goals and disseminate our research findings and co-develop these technologies. So these efforts, again, are very important. It's also very important for people to realize that you can do your part in terms of contribution to this humongous problem, especially when your interest is IT. But there are many ways to do that. It's not just simple things like being able to conserve, develop this methods here and there, but there are tons of ways that you can contribute in order to be sustainable. And some things may not be very obvious, but maybe using very much of global energy. The other thing is I think Desert one mentioned that. So water desalination also is a huge energy consumer. Ginormous energy consumer to desalinate water. So again, that's one field where people may tackle using the latest and greatest research and science technologies, including supercomputer simulation and analytics. So if you crack that problem, then again, the benefits are huge.
Thank you very much. So of course, we can take initiatives from a personal level and from the public and private sector as well. We are going into the last section that we will keep this room open until 8:30. But before we end the panel discussion, I would just like to ask the speakers to share a short take-home message for our audience. Maybe 1 or 2 sentences would be nice. May I ask Dr. Satoshi to go first?
Okay. Yeah. So again, maybe I'm repeating myself, but again, if we are on this incremental path, there's just no way of solving this energy problem, because the amount of population increase and the ever increasing energy demand, due to the fact that we want the middle class is increasing, like in a country like China, and also in India, eventually, middle class will bloom, and that will, and without a doubt, there's just no way we can control the amount of energy that's required to sustain a global being. And things like COVID actually is accelerating that, because people stay indoors and they use more energy as a result. So so the only way you can solve this is through this comprehensive applications of innovative technology. That's only can be driven by these very high goals, and with very smart people and smart young people, that will take some lessons from us older people, but create new innovative technologies and methodologies to tackle the problem. So so the future is bleak. If you just think of the numbers of to keep everybody sustained. The future is bright, because I'm sure there'll be tons of people who will be challenging these problems. Because think about 100 years ago what we were doing, we were hopelessly much less efficient back then, or didn't have the technology portfolio we have now. And so in the coming years, the future may be bright. But again, people need to work and collaborate and develop innovative technology to do that. Like I've been doing for years.
Right. You are a great role model for the young people out there. So I hope we can take lessons from your discussions today. But may I ask Rita about your take-home message from today's discussion?
I think is a little bit picking up what Satoshi-san was saying. We need to combine, going from the baseline of the materials that we source and the technology advancements, and then combine with the rest of the infrastructure to really ensure that we have a long-term sustainable strategy towards the decarbonization. My second main takeaway is that particularly in specific countries, the effort from different companies needs to be combined so there is more influence towards change at the public sector level that will accelerate the necessary decarbonization strategies and strategies at the country level. Otherwise, working in silo is very difficult to achieve, not only in terms of the effort required to achieve a goal, but also in terms of the outcome of this goal. Now, if we are working alone, we are not able to create as much impact as if we collaborate with other companies. So yeah, I think decarbonization goes very hand in hand with technology, and I'm really excited to see what this will lead.
Thank you very much. So I think I would just like to share this final slide with you before we end this session. So thank you everyone for joining us for this discussion today. We are at the end of our time, but we would really like feedback from you so that we can improve our future sessions. So please go ahead and scan this QR code and send us your feedback. We appreciate everything that we can get. Having said that, we have time until 8:30. So if you want to stay here and discuss more with the speakers, if speakers would like to stay here, but feel free to join us in more discussions right now. Thank you very much for joining us today.
Thank you. And thank you for this wonderful session.
Thank you very much for joining us, Dr. Satoshi. We understand you have a very busy schedule. And Rita, thank you so much for accepting our invitation for today's speech.
Thank you so much. I'm very happy to be here.
Yeah, it was my pleasure, Rita.
Nice to meet you, Satoshi-san.
So would any member of the audience like to share their impression or any thoughts about the event? Did you guys like it, or do you think we can improve in some way?
Yeah, well, I think, of course, it would be interesting to make introduction of everybody, but if it's 20 people, of course, it's a big challenge. So it's always a little bit pity if you don't know who the others are. But besides that, it was very interesting. And of course, the whole energy problem is actually now after COVID or with COVID still, I think it's the really big challenge we have to tackle. So such examples are extremely important to see how we can go further. And I was just thinking about also the complexity of many things. So I remember I did my PhD in Switzerland from 1990 to 94, and now I'm drinking here the beer can. And at that time in Switzerland was a big discussion that these multi-way bottles are better. But the point is very easy. If you buy a box of beer with 20 bottles, you go with your car to the supermarket. But maybe you just bring home a few cans in the evening. So in that case, then even the can is environmentally better than the multi-way bottle. So I think this complexity has to be discussed. And if I think of Amazon, I also sent a message concerning that. Sometimes I have several deliveries per day. Mm-hmm. So I think, especially now with the Corona, the delivery is increasing crazily, and that if the cars are not driving with renewable energy, then this is a pretty big problem. And especially here in Japan. So I started here 20 years ago for Fraunhofer, which is a big German research organization. And we started with the topic recycling and renewable energy also, but recycling and environmental things, and especially logistics. And in Japan, logistics is still optimized on fast delivery, which is so perfect here, which I think no other country can match. So I even had 4 weeks ago, I had a sake tasting through the internet. So I could order, and they sent 4 bottles to me. So I could sit here and enjoy the sake while the brewer himself was showing all the details. So this is fantastic. And I think that wouldn't work in Germany so easily, only because of delivery. But of course, it's just, this just-in-time thing is, of course, not always considering environmental costs. So I think we have a very complex system we have to optimize to really get better results.
Yeah, it's definitely challenging to decrease our carbon footprint with logistics. However, I put on the chat, although counterintuitive, faster delivery is not always a bad sign, because we minimize the distance traveled by our trucks, and we decrease the connections that we need to make in our network to have that package delivered to the customer. So if we would have, imagine a mega fulfillment center that would cover all Japan, in the center of Japan, the distance travel would be much greater, although it would not be as fast to meet our customer demands. So we optimize our network where our customers are. On top of that, we have several efficiency programs in parallel with the adoption of electric vehicles to ensure that we are decreasing our carbon footprint. We have a metric that we call carbon intensity. That is measured across different business units. In transportation, we measure carbon intensity per shipment, and there is a significant improvement based on all the different projects that we are rolling out, not only internally but also customer facing in Japan. So, for example, we are expanding our locker in Japan, which means that we don't have to knock on the customer home, and there is always someone there because the locker is there. It doesn't go anywhere. It cannot enter the door. We also have what we call unattended delivery. That it was rolled out, as an answer to decrease unsafe behavior and to minimize contact between people during this time. But of course, it also ensures that even if the customer is not home, the customers receive the package. So it means that we are not bringing packages back and try to deliver again. So everything that we are doing in the transportation sector has the ultimate goal of improving efficiency in transportation, which is directly correlated with the reduction in carbon emissions. And again, on top of that, we are introducing as much as we can electric vehicles, or what we call zero emission vehicles, that can also be, in Japan is very popular, the walkers and bikers, and some of our partners have this delivery option as well.
Well, this whole COVID situation has had a significant impact on the overall continuous recent trend in terms of advancing the shared economy concept. Just everywhere from the shared cars, shared bottles that we mentioned, shared everything. But it's been because of this for the fear of transmission or infection. This has taken a huge step back. I mean, when you think of everything, all the businesses that closed, that have been shut down, or businesses that have been compromised, most of the situation has been that these are the transmission occurs because you share something with some people, space, cars, whatever. Right? And so the internet and all the IT was driving the shared economy. which was supposed to make our, the overall livelihood more efficient. But, with COVID, this has had a significant negative impact. And in some cases it has, but think of people, now commuting by cars, which is less the case in Japan, but now globally, more people are commuting by cars, or compared to public transportation. And you might think, okay, we're doing this thing over Zoom, so so there's not much transportation. On the other hand, each of us stay at home all day, so we don't have so the energy consumption has gone up because people don't go to the offices, and as a result, the shared space efficiency of centralized offices have gone down the drain. So so all this, so the implication of this is we have to have a brand new design if this is to persist. So nobody knows if this will persist. In terms of a continued infection occurring because vaccines may not be that effective, or some other new pandemic may occur, or it can be temporary. And we had a sort of a crossroads where it may turn out this whole phenomena is temporary, that we can go back to this drive towards sharing economy, or that this is something of a long-lasting change, and that we have to basically, change our direction, change the plans, become more efficient in the presence of the lack of this sharing. So it's a big decision point. But both the society and the businesses that are trying to exploit the situation, try to have a business model, because a lot of people were directing their stuff towards shared economy. Now all these have gone down the drain, and this, so it's a very I would say critical situation because of this. I mean, some things can be shared, like the cloud, safely, because I think viruses don't transmit over the wire. Hopefully not. Otherwise, be infected using the Zoom. But otherwise, physical contact, spatial sharing, everything is a lot of these things people now shy away from. Big cities, efficiency of big cities, that's going down the drain. And people now moving to the countryside, but that's not a very efficient society.
Well, in a way, I mean, if people start to move away from the big cities, it's not so bad, because at least it balances a little bit more the economy. People have a better quality of life, and we have people, especially in Japan, that commute 3 hours a day to reach the office, and now they get those 3 hours back to spend with their families. So I guess it's a double-edged sword. No, it's good in some ways, bad in others. The changes that this is driving. I think the main lesson learned for companies overall, and we see these even across Japanese companies that tend to be more traditional, is there's no need to be in an office to perform the work. And to your point, yes, maybe while this transition is happening, we have offices still operating, although empty, and we have people at home consuming more energy at home, but at some point we will start to balance out a little bit more. It's an interesting time. I'm sorry about the publicity I'm sharing here in case people are curious about. We have a very extensive blog that we update almost daily on the actions that we are taking as Amazon, both internally and to the communities and to our employees in terms of COVID preventive actions and relief funds and support efforts. So just sharing in case everyone is curious.
Well, maybe one comment. I think the time you saved by not commuting, you spent actually with Zoom and all this thousands of web meetings.
Yeah,
that is putting some pressure on the cloud system for sure.
Unfortunately, yes. I think I have more meetings now than ever, unfortunately. Not fun ones like this, but with politicians and bureaucrats as well. And, they're a good bunch, but sometimes, have to have a very different frame of mind to speak to these illustrious people.
There was an interesting move now from the mainstreaming companies, including Amazon Video, but Netflix. Sorry, I'm missing the other names now, and YouTube. That they defaulted to have lower streaming quality that actually decreased over 1/3 of the energy needed, and kind of saved a little bit the internet worldwide to not having a surge of demand. And this again was back to the point of working as a partnership. This was possible because all the companies are working and addressing the same issues. Then even if they are competing in some cases, they are collaborating in others. And this was a great example where all the companies aligned very quickly to make these changes happen globally. I don't know if you noticed or if you were aware of this. So Satoshi-san was aware. I don't know if you had
oh yeah, the internet traffic. Internet traffic is like over 90% media from the data centers. So right now, I mean, it's essentially internet is a majority of internet capital is spent on being a content delivery network. So obviously, if you throttle on the data center side, of course, that'll say not only data center energy but the internet energy as a whole. So it has a big effect. Of course, that compromises the quality, as you say, but that's something people may have to live with, because but this whole business of that's a very interesting point, because this whole business of the internet representative, but a lot of the other things are. A lot of the other initiatives as well are becoming much more distributed as a result of the COVID-19 making us more distributed as a whole. Right? Like in the U.S., the federal government has a governing role, but each of the state has much more authority over its own governance compared to other countries which are more centrally governed, like Japan and France and so forth. But if you look at today's situation, the governors, each of the prefectural governors in Japan are seem much more independent, and they're sort of some are like rebelling against the central government because they're not as effective. Like if you look at Osaka, they're much more the governor there is very, very vocal and provocative against the central government policies, and this is sort of unheard of in the past. So it's making everything very distributed, which is, which on one hand is you optimize towards the local situation, and including things like energy policies, but in some cases may make it more difficult to have these unified policies, because, for example, the European Union regulations regarding this various energy policy were only possible because it's just this big union. Right? It's one central European government that's setting these disciplined goals that people have to meet. But it's all distributed. There's no, of course, obviously there will not be any central policy. So so if things are becoming more distributed by COVID, people living more separately, people pursuing your quality of life is also a very distributed activity, because people have their own values. So people do different things. So how do you federate people's interests in a way such that you achieve the sustainability goals, which is a central goal. But people with when people have, or governments or people at various levels have different objectives. So it's a very interesting governing question. Again, this whole COVID thing has thrown us in front of us this very interesting societal question of how do we pursue our own goals, personal goals or local goals, while being try to achieve this unified goal of sustainability. That's it's a very interesting philosophical question. How do we do that? What's the most effective?
Yeah, I mean, we get this question a lot. we slow down our efforts in sustainability? And the answer is no. No. Again, I think globally we become more conscious and aware of how we are connected and how things can change quickly, and therefore we feel a stronger responsibility to honor not only our commitments, because our commitments don't benefit just our customers, they benefit communities, they benefit the environment overall, and they also help to create and to align with other companies that are pursuing the same goals. Therefore, creating this wave of actions that in the long term will have a positive impact in the environment. Of course, exactly how COVID will change everything, I think we are still trying to answer that question, and we have to wait and see. Is definitely unprecedented times, and this is not being easy. And the employment rates are going very high, even in Japan, that was known for being a very safe country in terms of employment. And yeah, I think it's going to create a massive paradigm shift in terms of how we organize society overall, and create a new set of skills perhaps that can help us to work together far away somehow.